Okay, so now I've got it recording. So Thursday will be my last lesson. So that means 2 lessons, to finish up on the lockers. There's one section at the very end, but we need to do calculus first to be able to do that. Okay, so we can't do that until we do calculus. However, I reckon over the next couple of lessons we'll get the rest of the theory done for lockers. You'll have some time next week to get some work done, and also be incorporating some theory lessons into that as well, so we're not further behind. Okay, so made up a bit of time, and yeah, you're going to have to all work to make sure you're all up to date as best you can, please. Okay, so the last thing we did on Friday, we looked at 11.4, which is the parabolas locker. Okay, so the locus of the point, capital P, that is equidistant from a fixed point and perpendicular to a fixed line, is always going to be a parabola. Okay, so we looked at those things. We looked at what a focus, directrix, vertex, focal length, axis, chord, focal chord, lattice rectum, have a giggle.
No, I giggled then.
And a tangent. Okay, so we covered that on Friday, and the information's all there, and I'll be referring to that through the next couple of lessons as we go. Alright, first one. So, here is your equation of the parabola, vertex at the origin. Okay, with the variable A, which is the focal length. Okay, and we'll talk about that in somewhere on today or next lesson. No. So, that is your y equals x squared style parabola. Okay, the notation's different. So you got y equals x squared. Okay, so you've got that part of it, and we'll look at the rearrangement of that to what you're familiar with. But first, we're going to look at the proof. So, the locus of a point P, moving so that it's equidistant from the point 0A, so that's the focus, right? And the line y equals negative A, is a parabola with equation x squared equals 4ay. Okay, so proof. 11.1. So we're doing the same sort of thing we've been doing the last 3 or 4 lessons. Okay, so now concentrating specifically on the parabola. So we've covered general locus equation, okay, meeting the criteria of that, and we also looked at circles, okay. So we have 2 points that are always at right angles with each other, will always form a circle, okay. When we have a point which is equal to another point, and the distance between another point and the perpendicular distance between a line, we will always have a parabola. So, in your diagram on page 76. Right, so you have the point P, x, y. Right, there's your axes, your x and y. You've got the point capital A, which is 0A. Okay, so we're at A units above the origin. And we have the line y equals negative A. So the point where it crosses the y-axis is the same distance between the origin and that point as it is from the origin to the point A. Alright, and then we choose a point B. Well, we have to have a point B so it's perpendicular. The line PB, sorry, perpendicular to the line, y equals negative A. Okay, so the proof. So we have PA, which is equal to PB. So we need to set that equation because they're equidistant. From the interval, is equal in length. And remember your distance formula, which had the square root of x2 take away x1 all squared plus y2 take away y1 all squared. Okay, so to remove the square root, okay, we simply square the length of these intervals. Okay, just to remove that square root, because eventually it just saves you drawing it out and all that sort of stuff. Alright. So we have the point P, which is x comma y. Remember that is your point that moves for the given condition, that PA is equal to PB. Alright, you've got the point A. You have the point A, which gives you a set coordinate, 0 and A. And A is the focal length. We'll talk about that and the significance of it in a moment. And B. So, we have the variable point x, which moves in relation to the point P. So the x coordinate, it will be the same value. no matter where it moves because it's perpendicular, but the y value is always negative a. So we've done this in the previous lesson where we showed the equation from a point to a fixed line and it represents a parabola. Alright, so let's make the p x2, y2, and then these two for their respective sides, x1, y1. So x2 take away x1 all squared plus y2 take away y1 all squared is equal to x2 take away x1. So I'm just writing the formula. All squared. Okay, so it's the distance formula without the square root because we have squared the interval. Okay, so removing the square root in the process. Okay, so PA will be on the left and PB will be on the right. So the next thing we need to do is substitute. So x take away 0 squared plus y take away a all squared, which is equal to x take away x. So we're just doing substitution. And y take away a negative a. Okay, so what's your sign? So it'll be y plus a all squared. Alright, so let's tidy up and expand. So we have x squared, so x take away 0, which is x, and x squared is x. Do not do the perfect square of this. Okay, don't do x times 0 times 2, then 0 squared. When it's trivial, then we just need to have the first term squared. Okay, plus y squared take away 2ay plus a squared. So we're expanding the left-hand side, the second bracket, sorry, on the left-hand side. Using skills we've already been taught and applied. Right, so x take away x, right, so any number take away itself will always be 0. So we have 0 squared, which is just 0, which equals, expanding the second bracket, which equals that on the right hand side. Right, so on both sides I have y squared and y squared with the same sign, so they will cancel because if I move one over to the other side, it'll become the opposite sign and it will simplify to 0. Alright. Also have positive a squared and a positive a squared. I'm left with x squared, negative 2ay on the left hand side, and a positive 2ay. I can't cancel because they are opposite signs. So when I move it over to the other side, it'll double the magnitude because of the 2 out the front. So we're left with x squared equals, and then we've got 2ay, and then move this over to the other side, becomes a positive 2ay. So x squared equals 4ay. Okay, and the equation of the parabola and how it sits on the, not where it's the vertex, but sort of how steep it is in terms of the curve, okay, will all be dependent on the value for a. Okay, so this is the standard concave up parabola. Alright, so x squared is 4ay, which means y. So I want y the subject, so I've got to divide both sides by 4a. So x squared on 4a. Okay, so that's your standard concave up parabola at the origin. Okay, so the focus, so the next 3 dot points in the middle of that page, the focus has the coordinate 0, a, and we've already talked about this in the proof. The directrix has the equation y equals negative a, and the axis, which is the axis of symmetry, is the y-axis, which has the equation x equals 0. Okay, they're the 3 for that specific style of parabola. Okay, question. Right, examples. A. Find the equation of the parabola whose focus has coordinate 0, 3 and directrix equation y equals -3. Right, so while we're getting an understanding of this, let's sketch it. So the focus is at 0, 3. The directrix has the equation y equals -3. Okay, so the distance of the vertex from the focus is the same as the distance from the vertex to the directrix. Okay. Now, something I mentioned yesterday, I believe. Friday. When I mean yesterday, I mean Friday. It seems like saying yesterday, but really it does. Right, so the parabola, so the focus will be inside the parabola, and the parabola never crosses the directrix. Okay, and that's the 2 bits of information you need for the orientation of your parabola. Okay, so the focus has got to be inside the parabola, and the parabola will never cross the directrix. Okay, with the vertex at the midpoint between the focus and the directrix. Okay, so we have our concave up parabola, which suits the orientation there. So that means the equation becomes x squared equals 4ay. That's the formula for the parabola of that orientation. However, we are given information about the focus in terms of the focal length. Okay, so it's from the vertex up to the origin has focal length A. Okay, and that A gives you the coordinate of the focus. Alright, so A is 3, and we substitute that into your formula. Okay, so x squared equals 4 times 3 times y, so x squared equals 12y. Okay, now the way you're used to it, if you divide both sides by 12, your equation then becomes y equals x squared over 12. Okay, for the parabola. However, for this topic, that's the format that you're going to have your equations in. Okay, so we've got the equation of that parabola. B. For the parabola, y equals, x squared equals 8y. So we've got 4 different orientations of the parabola at the origin. You need to know the format of the equations for all 4 of them. Okay, the x squared equals 4ay is your concave up at the origin. Okay, and we'll do the next 3 shortly. Right, find the focal length. So, if we do a quick sketch, alright, this is in format x squared equals 4ay, so we have our concave up parabola. Okay, so part I, find the focal length. In other words, find the value of A. Okay, so the format is x squared equals 4ay for our concave up parabola, and then matching your variables, 8 must be equal to 4a. So 4a equals 8, so a is equal to 2. So the focal length, so it's the distance from the vertex to the focus for this particular parabola, is 2 units. Okay, that's what that's referring to. That's the focal length. So the focal length is just finding the variable A. Part 2, find the coordinates of the focus. 0, 2. So we've got our concave up parabola at the origin with the focal length 2. So 2 units up from the origin. So the focus has coordinates 0, 2. find the equations of the directrix and the axis. Okay, so what's my equation of the directrix going to be? Equation, not coordinate.
Oh.
Right.
Y equals
Negative 2.
negative 2.
Alright, so the distance from the vertex to the focus is the same as the distance from the vertex perpendicular down to the directrix. Okay, so we cross the y-axis at negative a because we've gone down, so the equation becomes y equals negative a. That's the directrix. Okay, so y equals negative 2. Okay, because you've found the value of a already. The equation of the axis. So the axis referring to the axis of symmetry. So which axis is my axis of symmetry? X equals 0. So in other words, the y-axis is the axis of symmetry. Because if I fold over on the y-axis, I'll get the same thing on both sides. Okay, and the equation of the y-axis is x equals 0. Okay, because it crosses crosses the x-axis at 0. Right, considering the lattice rectum, we need to sketch the parabola. Okay, so I've already done a quick rough copy just to get the orientation right. Considering lattice rectum. So, over on page 75, the focal chord, so we've got a chord that interval that joins any 2 points of your parabola. A focal chord is that chord that goes through the focus. And the lattice rectum is the focal chord that is parallel to the directrix. Okay? So, looking at the diagram on page 75, we've got the axis, the lattice rectum which is parallel to the x-axis or parallel to the directrix, or perpendicular to your axis of symmetry, and it has length 4a. So length is equal to 4a, 4 times the length of the focus. So the focal length is 2, or the value for a equals 2. Alright, so 4 times 2, which is 8. So in other words, the distance from here to here is 8 units. Okay, the reason why I was asking you, because you can do the, you've already got the vertex at 0, 0, and then you can plot those 2 points to do a more accurate sketch. Right, with your rulers, let's draw up a nice, let's draw up a straight axis. To pair when you use rulers on the boards. Right, so I don't have a ruler, so mine's not going to be ruled up. Okay, but use your rulers please. X, Y, we know the point 0, 0, the vertex. We have the equation of the directrix, y equals negative 2. We have the coordinates of the focus, 0, 2. And then the endpoints of the lattice rectum. Okay, so we've got a distance of 8 overall. That means half the distance is 4. Okay, so we're going to have the coordinate 4, 2 and negative 4, 2 for the endpoints of the lattice rectum. Okay, and that will give you your 3 points to do your parabola. Okay, so we're not overly concerned about accuracy, but we are that you can accurately represent the information onto a graph. Right. Well done.
Yep.
So, part B. Find the equation of the focal chord that passes through the point -8, 8. You all remember how to find an equation of a line. What two things do you need? Find the equation of a line. You need what?
3 points?
Hey?
You need 3 points?
Well, technically you need a point and a gradient. But to get our gradient, we will need 2 points. Okay, so in this particular question, we will need 2 points. So we've got one of them.
The focus.
Good. Okay, so the focal chord goes through the focus. And the focus had equation 0, 2. Right, so let's find the equation of the gradient. Y2 take away Y1 on top, X2 take away X1 on the bottom. Remember the gradient is the rise over the run. X1 Y1, X2 Y2. So we have 2 take away 8 over 0 take away a -8. We've got -6 over 8. So -3/4 for your gradient. Okay, remember fractions are always simplified down to simplest form unless told otherwise. Okay, anyone remember the point gradient formula? Yep, that's the equation of a line, but the point gradient formula. Y take away Y1. Can we finish it?
X taking X1?
What's that from? What did I just find?
Oh, gradient.
Do you remember this? Yep. Okay, you'll be using this a fair bit in your course, in your coordinate geometry work. Right, so I'm going to use 0, 2. Okay, so pick a sensible point. Okay, so I'm not using negatives, for example, and I'm using a 0 as well. So, x1, y1 is the x2, y2 at the top. Y take away 2 is equal to the gradient times x take away x1, which is 0. So y take away 2, which equals -3/4 of x. And then move the -2 over to the other side and make it positive. So you get your y equals mx, the gradient times x plus the y-intercept. Okay. Have you guys done general form as well? Okay, we'll look about more detail in your geometry, coordinate geometry, but that will do for what we're doing here. Okay? Right. Question. Right, over the page. So, there were 4 equations, so 4 ways the parabola can lie on a number plane with the vertex at the origin. Okay, so depending on where the focus and the directrix are, alright, will depend on the orientation of your parabola. Okay, 4 different ways this can sit. So, x squared equals to negative 4ay. So we've just done x squared equals 4ay, which is your concave up parabola from the origin. Now looking at that, what would you suggest the orientation of the parabola would be? Okay, concave down from the origin. Okay. So, the locus of a point P moving to the equidistant from the point 0, negative a. So the focus is now below the origin. And the line y equals a, so the directrix is now above the origin, is a parabola with equation x squared equals negative 4ay. Okay, so you've got the diagram in front of you, 77. Okay, so you've got the focus below, you've got the directrix above. The focus, always sits inside the parabola, and the parabola never crosses the directrix. Okay, so you're told you have a negative focus. Okay, so in other words, below the origin, the directrix had a positive equation y equals a, the focal length. Okay, the vertex of your parabola is always halfway between the focus and the directrix. Okay, so the vertex is going to be at the origin because distance is the same. The parabola will sit inside the focus, okay, but it will never cross the directrix. Okay, so your parabola is then something on the lines of that. Right, so I'm not going to go through the proof because they're exactly the same as what I did, just to change a variable. Okay, I just want to get through all these examples in the next 20 minutes. Alright, so the concave down parabola. Okay, so x squared equals negative 4ay means with the y equals negative x squared on 4a, and that's what you're used to. Okay, but we need to now get used to this notation. Okay, so we have the focus at 0, negative a, directed with the equation y equals a, and the axis is still the same, the axis of symmetry. Alright, example C. Find the equation of the parabola whose focus has coordinate 0, negative 5 and directrix equation y equals 5. Okay, so sketch 0, negative 5. So y equals 5 is the directrix. Okay, and those two bits of information will tell you the orientation and the vertex of the parabola. Okay, so the focus is always inside the parabola, and the parabola never crosses the directrix. Alright, so we have this. Okay, it's the only way the parabola can sit that will meet those two conditions. Right, so what is the equation? What's the format of the equation? Okay, negative 4ay. What is the focal length? Well, it's the length, so it's positive, okay, and the negative will be already taken care of in the formula, okay. So not substituting negative 5 because then you'll change your equation to a concave up parabola, okay. So the signs out the front will take care of the orientation of your parabola. So the focal length A is 5, the distance from the origin to the focus, and distance is always positive, okay? So x squared becomes a negative 4 times 5, which is negative 20, so the equation becomes x squared equals negative 20y. Alright, D. For the parabola, x squared equals negative 4y. We need to find I, the focal length. Alright, so you rewrite the formula for the orientation of that parabola. So x squared equals negative 4ay. Write the equation. And then negative 4 must equal negative 4a. to find the value of A. Okay, so negative 4 is equal to negative 4A, so include the sign. Therefore A is 1. There are only 1 unit for the focal length. Okay, so the shorter the focal length, the steeper your parabola is going to be. Right, part 2, find the coordinates of the focus, and part 3, find the equation of the directrix. Okay, so it'll be handy now to do a quick sketch. So you get negative, x squared equals negative 4y. Okay, so there's your orientation. The focus is inside, and the directrix never touches the parabola. Okay, going back on that perspective. So we have just calculated the focal length of 1. That means the distance from the vertex to the focus is 1 unit, and it's also the distance from the vertex to the directrix. Okay? So focus is at where? Focal length, what you just told me. What's the coordinates of the focus? 0, minus 1. Okay. Right, so you go nowhere along the x-axis, you go down 1 on the y-axis. So the coordinates are 0, negative 1. Right, the equation of the directrix. So it crosses the x-axis or the y-axis? Y, so the equation becomes y equals, and what point? 1. So y equals 1. Alright, type 3. Y squared equals 4ax. So we just had an x squared equals 4ay, which is your concave up parabola. X squared equals negative 4ay, which is your concave down parabola, both at the origin. Now we have a y squared equals 4ax. So what would you suggest about the orientation of this parabola? On the side, okay? Opens up on the positive x-axis. Alright? So, the locus of the point P, moving so it's an equidistant from the point A, 0. Alright, so A, 0, which is out here. So now I've got the focus on the x-axis. And the line x equals negative A. The x equals means it cuts the x-axis. Okay, and that is at point negative A. Okay, so remember the distance between the vertex and the focus is the same as the distance from the vertex to the directrix. So that means the vertex of the parabola will be at the origin. The focus is inside the directrix and never crosses, the focus is inside the parabola and the parabola never crosses or touches the directrix. So we have an opening out on the positive x-axis of a sideways parabola. Have you done much work on sideways parabolas?
Never.
Alright, that was introduced in there. Alright, so again the proof is very similar with the variables there. Got to change them for what we had. We'll just get through the examples. Alright, E. Do it this side. Right, E. So find the equation of the parabola whose focus has coordinates 2, 0. So let's put that in the diagram. So 2, 0. And directrix equation x equals negative 2. So x equals means it crosses the axis at the value of it. Okay, sketch your parabola. Okay, so the focus is always inside the parabola and never crosses the directrix. Right, so you need to recognise the notation. Right, sideways means the y squared, and it opens out on the positive x-axis, so it's a positive sideways parabola. Okay, that's the formula. However, we know the focal length, so we can substitute in for A. So what's the focal length? 2, the distance from the vertex to the focus. So that means the equation becomes y squared equals 8x. Okay, so how the parabola opens or closes depends on the value of the focal length. Alright, F. For the parabola y squared, which is 18x. Alright, so it matches this equation. So you need to recognise it is a parabola of that form. Find the focal length, according to the focus, and the equation of the directrix. Okay, so one of the things you need to do is recognise your 8 different equations. Okay, so we're covering the first 4 because the vertex is at the origin. So y squared, because this is positive, okay, means my y squared is equal to 4ax. It's that orientation. Right, so 18 must equal 4a. So 4a equals 18. Okay, 18 over 4, which is 9 over 2. Okay, remember the fraction simplified, or you can say 4.5, or 4.5. Find the focal length units. Did I do that before? Okay, can we go back to question D, last example. It says find the focal length. Can you write units as well? So when you ask for focal length, you need to give units. Okay, so that's the value for A. 4.5 units. Alright, so we've got the focus, which will be 4.5, 0. Alright, because we've got the parabola sitting this way. Okay, and because that's the vertex, it'll cut the x-axis at -4.5. So from that, find the coordinates of the focus. Just labelled it. Focus at 4.5, 0, or 4.5, whatever you want to write. I haven't specified what you need to write it as. And what is the equation of the directrix?
X equals -4.5.
Yep, okay, so it crosses the x-axis, that means x is going to be the subject, and it crosses at -4.5. So the equation is x equals -4.5. Any questions? Right, one more. So we have y squared, which was 4ax. So the last one, y squared, which is -4ax. Okay, so just like the concave up had a concave down when you put a minus sign. So the concave out to the concave right, I don't know what notation it is. Okay, we'll also have an opposite. Okay, concave in negative direction. Okay, so the vertex at the origin, the focus is inside, and we'll have coordinates -a, 0, because it's in the negative x-axis, and the directrix will cut the x-axis at A, and the equation will be x equals A. Okay, so the locus of the point P, moving to the equidistant from the point negative a comma 0, which is your focus, and the line x equals a, which is the directrix, is the parabola with the equation y squared equals negative 4ax. Okay, again the proof is very similar. Substitute those variables into the first equation that we've done, and you will get that equation. Alright, G. Find the equation of the parabola whose focus has coordinates negative 6, 0. So negative 6, 0. And directrix equation x equals 6. So x equals means it crosses that axis at 6. The focus is halfway between, the vertex of the parabola, halfway between the focus and the directrix. Okay, poorly drawn, but there's the orientation. Okay, so it opens out in negative x direction, so the equation becomes y squared equals negative 4ax. And what is the focal length? 6. Okay, the distance from the vertex to the focus is 6 units long. Okay, so that distance is 6 units. Alright, so we simply substitute in 6 for the value for a. So a is 6, so y squared equals negative 24x. Right, last question, H. For the parabola y squared equals negative 120x. Okay. Part I, find the focal length. So how do we find the focal length? Good. Yep. Divide 120 by 4, or in other words, y squared equals negative 4ax. Write the equation of the parabola at that orientation, and that means negative 4a must equal negative 120. Include your signs. Okay? When you include your signs, the focus will always be positive. The value for a, will always be positive. So what's negative 120 divided by negative 4? So we've got a focal length of 30.
That's pretty big.
That is a very big focal length, and it will change the orientation of the parabola. Double I, what is the coordinates of the focus? Alright. What is the coordinate?
30, 0.
Sorry?
30, 0.
30, 0.
Well, thinking about their orientation first.
Oh, negative 30, 0.
Okay, so negative 30, 0. Okay, because this parabola sits this way and the focus lies inside the parabola. Directrix. What's the equation of the directrix?
X equals 30.
Good, okay, it crosses the x-axis. And that will give the location of the parabola. And the orientation, of the parabola. Right. Very good timing. So, there were 4 equations of the orientation of the parabola when we are at the origin. Okay? So, on Thursday's lesson, we'll be looking at the 4 when the vertex is not at the origin and how it changes our values of focus, directrix, also the location of the focus, directrix, and also the vertex of the parabola itself. And we'll cover that on Thursday. Right, any questions?